Welcome to the Operations Science Podcast, where the art and science of operational excellence come to life through captivating stories of triumph, challenge, and transformation from the front lines of industry. Our distinguished guests, from manufacturing pioneers and medical device innovators to aerospace visionaries, diagnostic lab leaders, and major capital project leaders, unveil the hidden patterns and powerful insights that drive exceptional results in the complex world of operations. Join us on this journey of discovery as we explore the brilliant minds behind the systems that make our world work and uncover the leadership secrets that could revolutionize your approach to operations forever. Here is your host, Ed Pound.
Welcome to the Operations Science Podcast. The opinions expressed by our guest are their own and are not meant to represent their company's positions unless specifically stated as such. Now, imagine being in charge of one of the largest airline maintenance organizations in the world for one of the largest airlines in the world, and the COVID pandemic hits. You must ground and then maintain one of the largest airline fleets in the world. You have no idea when the pandemic will end. Then, your organization is responsible for restoring those aircraft safely to flight operations as commercial aviation emerges from the global shutdown. Supply chains are in chaos. Your workforce has been vastly reshaped. Now imagine not only stabilizing that operation, but transforming it into one of the most innovative and efficient maintenance powerhouses in the industry. My guest today leads an organization that supports over 900 aircraft, provides maintenance, repair, and overhaul, or MRO services, to more than 150 other operators worldwide, and is at the front of building and industrializing engine shops for the next generation of aviation. From ground level experience to executive leadership, from wrench turning to wide body strategy, this is a story of resilience, reinvention, and the science behind superb, sustained operations performance. Please welcome to the first ever Operations Science Podcast, Mike McBride of Delta Tech Ops. Welcome, Mike.
Well, hello, Ed. Thank you for that very eloquent introduction.
Well, it's an exciting business. I mean, that's an incredible experience to go through. I mean, you've been part of Delta through some incredible transformations, especially coming out of COVID.
Indeed.
So looking back, what would you say were the biggest operational challenges that in that post-COVID environment, and how did your team approach solving them?
Wow. So long list of challenges thinking back to those days. But, coming out of the pandemic, restarting the airline, obviously the supply chain suffered pretty tremendously through that period. So shortages abound. We burned through a lot of inventory that, just had been there to buffer turn times and other things. But, we also lost many, many thousands of hours of experience with, early retirements and the various things that we went through from a workforce perspective. So, mix in some new product types. There were some new engines just coming online at the time. So, new people, new engines. The old engines had supply chain problems. The new engines had supply chain problems. So, turnaround times went from, 75 days to 300 days, and that really an availability problem from the perspective of service levels for the customer, which is our airline and the airlines that we serve from an MRO perspective.
Right. So, I mean, I think I remember the number I heard batted around was something like 50,000 hours of people out the door. Now, explain a little bit about that. As I understand it, because you couldn't support a large workforce with no airplanes flying and no revenue, there were a lot of nice buyout packages. Is that right?
Yeah, there were just a lot of packages offered to people we had a pretty senior workforce at the time anyway. So, those buyout packages were attractive enough to get people out the door and really reduce the workforce by, probably 35, 40% at the airline from just a maintenance labor perspective.
Wow. So that's huge. 30 to 40%. Over what time period? I mean, that was over a year or a couple of months, or how long is that?
Well, that happened, in the early days of the pandemic when it was clear that we weren't going to be flying, after we had parked airplanes. And it was clear that, the airline was in survival mode. So that happened during the pandemic. And, obviously the hiring frenzy didn't start until after, it was post-pandemic. It was 2021, late 2021. So that was a big task to rehire and retrain. Some of the training cycles, depending on what type of work a technician does, can be 2 to 5 years long.
Wow. So let's go. One of the things I found interesting when reading up a little bit about the COVID, when you park aircraft, you don't just park them out there and leave them for a couple of years. Describe a little bit about what you have to do to make sure that you don't lose them from being parked.
Well, yeah, airplanes like to fly. They don't like to sit. Generally not super healthy. So you have to perform monthly checks that are, they're regulatory requirements to keep the airplanes basically, flight worthy, airworthy, as we say. So there are checks that have to happen over the course of, having that aircraft parked. Otherwise, if you just park it and don't do anything to it, it falls off of the operating certificate, and it has to go into a much heavier maintenance visit to be reinstated to the op certificate. So, so a lot of work going on in the desert and various places where we had airplanes parked just to keep them, airworthy, so that when the airline did rebound, we had the ability to bring them back. And some airplanes we just parked permanently. We parked the 777 fleet and never brought it back.
Really?
We intended to park the 717 fleet, but because the resurgence in air travel was so rapid, we wound up bringing that fleet back because we needed the lift.
Wow, that sounds fascinating. Yeah, it's not just putting it in the parking lot and leaving it there. So in terms of dealing with that, now, okay, so leave COVID behind. Now you're getting started back up, and you've got a new workforce. Talk a little bit about how you brought the organization back online.
Yeah, well, a lot of things that you wouldn't have thought of. I mean, just, process-wise, we had never had such a large group of people that had to be trained at one time. Mm-hmm. And so, we had to rethink how we train people. So we had to rethink some of the, in an engine shop where you have a disassembly, that flows through an assembly side. So you have a disassembly area, parts go into repair, and then parts are collected back to the final gate before reassembly. But there are a lot of modules. Engines are modular, so you have a compressor, high pressure and low pressure compressors, and high pressure, low pressure turbines. These different modules, and we used to, be able to work people through the process, kind of from disassembly, which is the easiest part to learn, through these different module areas to assembly. But we only had a few new people a month. In any given month, you might have one or two. There's just not much turnover. And then suddenly every month we had 20 people to train, and we also had to build engines. And so we had to stop and rethink, the whole build process and think about, okay, we can't train the way we used to. We're just going to train this group of people to do this specific module and this group to do that specific module, and create little sub-factories within that line just to get through the actual training curve, which lasted probably 18 months. And in the meantime, a lot of material shortages that were driving extensive turn times. So whips started to build in all the shops, and turn times got prolonged. I think most engine lines in the industry, not just ours, but, they got up around 200 plus days. Some of them even close to 300, whereas wow. what our typical our typical world prior to that was somewhere between 75 and 150 days, just depending on the engine type and how heavy the work scope was. But there weren't many engines that went past 100 days. In fact, one of the things we used to do was we would have it was kind of a birthday, we would call it, 100-day we would have a centennial day, I guess is what it was. We'd have a centennial day for any engine that went over 100 days because nobody, none of the managers of any of the engine lines wanted an engine to go more than 100 days. So it was kind of a, negative thing for you to have a centennial celebration. It wasn't really a celebration. It was kind of a joke, but So, you can imagine when engines started to go, 200-300 days, how much impact that had on the operation and how much that restricted the flying fleet. So a lot of challenges with that stuff.
Yeah. And
so a lot of different, things just changed overnight, it seemed like. But, and so then the planning has to be done different. And so you because of all these things together, you have a very chaotic you now have a very chaotic production process. So within about 6 months of the recovery, we sat down and said, okay, our goal has to be stability. We've got to go figure out how to stabilize these production lines. And so that was really the first year, was just trying to get back to a cadence, repeatable processes, ensuring quality and ensuring the training cycle was working, and those airlines, but to other customers as well. And to do that efficiently and to do that, as cost effectively as possible. And, it's a complicated business, but it's not one that you can't, stabilize and have a really clear expectations around how it should operate. So, and of course, as you know, that's where the science comes in, right? That's where the fun starts.
Yeah. So just real quick, you talk about taking down an engine and repairing every part. How many parts are on an engine?
Gosh, I don't know. I've been doing this a long time, Ed. Thousands. I don't know.
Still counting.
Yeah, many thousands.
Yeah.
I don't know though. Yeah, there's, the bigger parts, what we call the rotating parts or life limited parts.
Yeah.
The fan and the blades and vanes and the discs and the shafts that turn, right?
Yeah.
Those are and then the cases that those things turn in. Those are the big, a lot of those have big repairable parts. And then some of those are life limited. They can only fly for so many hours or cycles and they have to be replaced.
Right.
But
there's a lot.
You'd be surprised, thousands of parts.
Yeah.
So, to manage that system, to forecast demand for any various, all the various parts, and it's a pretty complex business.
Yeah, a lot of variability, definitely. So let's get back to where we left off there, where you were talking about stabilizing the organization. So describe sort of that process. After the first year, you stabilized the organization, and now what's next?
Well, we were kind of working some parallel paths. It was interesting because one of the things that we did during COVID was some of the engineering team had some ideas around improving some forecasting models and things like that. So one of the keys to having the materials on hand when you need them is forecasting what we call scrap rates. So when an engine comes in, there's a certain number of parts that, they're beyond repair, or they will time out, or they will have had other problems that create a need to scrap that part and replace it. And so the engineers had been working on some improvements to that modeling process, and they got pretty deep into that during COVID. And so one of the things they did, and they had an AI engine involved, and ultimately got to where they had a much better predictability of scrap rates for an engine, and they also had the ability to do it much further out.
Wow!
So they could take the operating parameters of the engine while it was still flying, and they're gathering all this data, and ultimately it's a dynamic model that continues to predict what the scrap rates are going to be right up to the day the engine comes into the shop. The other thing that we started to do in conjunction with that is we were, previously we treated the airline very much as like a fleet maintenance operation would treat the engine. So instead of being, engine specific, we were fleet specific. So we would take all 757 engines and we would say, this is the budget for the year. This is how many we expect to have to overhaul or repair. And we treat it, you'd have some winners and we shifted to a serial number specific management. And there were a couple of reasons for that. One was because of the supply chain disruptions, we needed to be able to see the flow of parts to each engine, and we actually needed to see that way in advance. So, the turn time for repair cycles prior to COVID was about 45 days, and it had turned into 150-day repair cycles for lots of parts because we don't do them all internally. A lot of them are done externally, and because of the new engines that were being produced, a lot of the OEMs and other avenues for repairing parts, they had so much other work around producing new parts for new engine types and everything else. So we had to be able to predict further out so that we could get ahead of the demand curve on the parts. And we had to also be able to start to channel parts to specific engines, way upstream of when the engine actually got here. And that required us to change some of the internal processes around how we operated with our planning systems and with our production management systems, and then starting to put into place, so that was all oriented around trying to get some stability around supply chain and material demand and all those types of things. We had all the training going on and trying to get stability around all of that element and really get consistency and get some drumbeat, get some flow back into the shops. Even at a ridiculously high turn times, trying to get a stable life back in, a stable environment, I guess, back in the shop. And so we had to look at, and we really started to look at whip control, and, we had shops that we always had max whip plans for every shop, but every shop was at max whip, and the engines just kept coming and the whip just kept building. Yeah. And so we had to go into a little bit of a whip, drain the whip off, kind of drain the swamp approach to things to get some stability as well. And then once we started to get a bit stabilized, then we could start to look back at some of the traditional things we were used to working on with whip management and all of the tools that we go in and examine, what turn times are on various parts repair and assembly functions, and, just kind of getting back to some level of normal metrics and that kind of thing, even though they were still inflated,
Right. So that kind of leads into your whole continuous improvement effort. We've got new people trying to get them to understand the system. It sounds like you've made some structural changes at this time to actually, as you say, manage the supply chain and change the way you manage parts. Talk a little bit about your continuous improvement efforts and how that evolved.
Well, one of the things that you lose in a kind of a COVID environment when you lose all those people is a consistent way to think about problem solving. That's so when you start to talk about, let's go stabilize the process. Well, what does that mean? People don't, if people don't speak the same language around, continuous improvement, then, or even just if they don't speak the same language around problem solving, then you're just going to flounder. You don't have a base. We started back we went all the way back to like basic lean tools like 5S. That was the first thing we did was, okay, let's just be good at housekeeping because we're not good at anything else right now,
Yeah, let's start somewhere.
Let's go get good at 5S. Let's go get some, let's try to stabilize this environment a little bit.
Yeah.
Keep the tooling where it belongs and keep the workplace organized and do all the things that we know how to do. And, with a new workforce, we had to teach them. So it went all the way back to that. So then it was really for me early on, I think probably when you and I first started talking, it was really about how do we get this language back into, reinvigorated? We still had people here that had been involved in this kind of thing for many years, but a lot of those people were gone. So the consistency around problem solving and just the lexicon of language, that you're using to do that, we didn't have that. So when people talk about, like design, implement, control, they're like, I don't know, what does that mean? And so, whereas those of us that have been doing it a while, I mean, we understand, well, that design part has your process map in it, and, you're modeling the process and you're optimizing the process. I mean, all those things that you think of, you take for granted after you've been doing it for 30 years, well, nobody speaks that language all of a sudden, or half the workforce doesn't. So, that was a lot of it. We had to really just kind of go back to how do we reteach, the science of operations to the workforce and the leadership, because we had a lot of leadership turnover too. It wasn't just that, the workforce, in some areas, I had one area that had 9 out of 10 managers replaced in a year,
Yeah, that's turnover.
That's a lot of turnover. And even, with very seasoned managers going out the door who already, could communicate with me and communicate with their leadership in a language that we all knew in terms of process improvement and, understanding, turn times and what goes into science-based control and all that kind of stuff, and so we had to start over with education and with some grounding in lean and kind of basic stuff.
Okay, so that's interesting because for the audience, Delta Tech Ops is one of the leading organizations in the world in applying operations science. They've been very successful training their people and providing this common framework that Mike, that you were talking about. Talk a little bit about that, how that process went, what some of the obstacles were, what some of the benefits were, and how that's going now.
Well, we started, I put together a small internal team. We call it Safety, Quality, and Continuous Improvement. And that was, again, that was kind of on the heels of this stability drive was, okay, let's make sure I've got professionals in here doing evaluations and risk assessments on the safety side that are making sure that we're, in the right place from a product quality perspective and that kind of thing. And then on the continuous improvement piece, I had worked, I think we did this originally with you here at Delta, 20 something years ago, the first time was it that long? No, it was probably.
No, it was, I think that was 2016. It just seemed like it was a long time ago.
Okay. All right. So it just seems like 20 years. No, it was 10 years ago. I'm sorry. So we had done that original work, and I thought, well, okay, that was very healthy, and that's what got us kind of into this kind of language of problem solving and understanding the dynamics of WIP and throughput and turnaround time. And, people, having been through lots of different continuous improvement paradigms in my career, one of the things I loved about the work we've done with you guys is, it's just the science of it. It's just the math. It's just understanding how things work. And it doesn't get fancy with buzzwords and things like that. It's just the kind of the reality of what's happening. And it's easy I think it's easier for our teams to latch on to, because it's just their reality described with formulas, and they can latch on to that and say, oh, okay, well, now I know why this is happening or that's happening. And so it's a very kind of direct connection to their day-to-day operations. And so we started back with some basic things like gimbal boards that are in the shop that describe the daily production and what's going on, what the WIP levels are, what throughput turn times are for various modules and things like that. And then we basically built created material for kind of a lean operations science training course. So we had your folks from operations science come in and work with us side by side. And in the process of doing that, some of these individuals on the safety, quality, continuous improvement team were essentially certified through the ops science organization to teach this material. I guess that took us about a year maybe to do all that.
Yeah, it was over the course of the year. It's not a full year's worth of work, but it was, people are busy. So you're not going to do that 24 hours a day. But yeah, it was over the course of about a year through 2023. Yep.
Right. And so people, it starts with really kind of an overview of continuous improvement and then, capacity and utilization and turnaround time and basic flow and that kind of stuff. So getting that language back out, and we've done that. We've continued to do those courses. I don't know how many we've done at this point. Well over probably close to 1,000 people have been through that at this point. And so lots of, the stuff that they do in the course, they go right back down to the shop floor, and it's there. It's on the gimbal boards. It's in the language. It's already something that they're hearing and using daily. And we followed that with some implementation of some new systems that actually create the daily information that goes on the gimbal boards, give you more drill down insight into the operation within a given area, what their daily demand is, and what skill, how to assign their workforces and things like that. So
planning,
but but it's all with an eye toward this notion of throughput and whip management and that kind of thing. So that was how we got started, and where we are today with that is we have stabilized. We have what we call legacy fleet shops. So we have 3 new engine shops. The Rolls-Royce shop that does all the major Rolls-Royce wide-body engines. We have the Pratt & Whitney GTF shop, which is the new geared turbofan engines. And then we have the LEAP shop, which is the new GE engine. All the other engines that are on the flying fleets are what we call legacy. So 757, 767, 737. So all those legacy fleet shops. So one of the things that we've, in a combination of these things I've talked about, between how we train people, how we change the way we look at forecasting, how we implemented operation science and our view of the production system and how that's evolved. On the legacy fleets, we are 2 to 4 times faster than just about any other shop in the world.
Wow.
From a turn time perspective. I looked at it the other day. We're on one particular engine 4 times faster on turnaround time than our next closest competitor. So, that has a lot to do with, says a lot about the different pieces that we put in place.
Yeah.
And comparatively, we haven't covered as much ground on the MRO side, just because some of the tools, like the forecasting tools, we're just now starting to use for customer engines. And it's a little bit different dynamic over there, but most of our Delta engines are almost twice as fast as the similar variant of a customer engine. But that's just because we haven't applied all of these things to those areas yet, and that's where we're headed this year. We're accelerating the application of that to some of our, the lines where we do a lot of customer work for other airlines to get those turn times down to something similar to what Delta is seeing on their fleet.
Well, it's been impressive. I tell you, I got, one of the things you hear when you talk about operation science, to cover that a little bit more is, you mentioned math and science and formulas. And so people will think, oh my gosh, that's very intimidating. I left math behind like in high school and haven't really been interested since.
Right.
But that wasn't the case. I mean, we're really, talking about multiplication, division, addition, and subtraction. And out of that, I remember one of the comments, it was fairly common comment. These were people who had been, because I went to a few of the training workshops as we were certifying the instructors, was nobody can tell me why we do what we do around here. Talk to that a little bit and about how operation science fits in with that.
Well, yeah, I mean, it's easy to get lost in the details of what you do every day. And so people, I guess I'll use Little's Law as probably the best example of how people can connect to different moves we make at a strategic level. And Little's Law, is just TAT's equal to whip over throughput. I mean, like you said, just a simple little division problem.
Just TAT being turnaround time is equal to whip over throughput. Yep.
Correct. And so a simple little equation, but a very powerful one in the context of strategy in a given shop, because your whip has a lot to do with your speed, and people, so for example, if I say don't induct this last engine this month, and people are, you might not understand that if your job is to tear down engines, in disassembly. And however, the overall throughput of the shop is impacted by that. So getting everyone on board with when they're looking at the metrics within the shop, they're understanding that, oh, we got too much whip, or we don't have the right balance here.
Mm-hmm.
So that kind of thing is what starts to get people connected. And the beauty of all that stuff is it's really, the math part of it is not something that is intimidating to them at all. I mean, it's because we don't just jump in and start writing formulas on a chalkboard.
Yeah.
They take this home and do it 10 times or whatever,
Yeah.
We start to talk about flow and dynamics, and we start to talk about it in kind of big picture ways. And people already understand it before you even get to the point of doing some kind of a calculation,
Yeah.
And so that's the kind of stuff that connects people. And then when you get to something like, best case throughput versus whip, kind of analysis where you're looking at that on a chart, they know what that means. They already know what that means before you ever start to tell them, oh, if you do it this way, you can, kind of project what your best case is going to be. And they what you find is that creates a bit of a desire for more. The class builds that way, and that's kind of part of the genius of ops science, I think, is the way that it takes a person through it in a very practical way. In other words, you're solving problems from the very start. You start solving problems, and you start building confidence, and you have, by the end of it, you feel really confident that you understand what you're looking at in some of these charts and whatnot. But you can also have an intelligent conversation about decision making relative to kind of some real-time operational stuff. So that's what I was saying earlier about kind of the language, right? I can go down now and ask one of the lead mechanics, hey, how's it going? And they'll say, well, we've got this over here, and he'll explain it in the language of operation science around, the compressor modules are having this problem, or this module shop's having that problem. And we talk about how that's impacting flow and throughput, and, where the line is being starved, or where, so there's a lot of conversations that, like I said, that it's probably better now than it was even pre-COVID. I think we had gotten a little spoiled with inventory buffer pre-COVID. You have these great turn times, but after COVID, we burned off all the inventory. We didn't buy it back. It wasn't like the airline had a pocket full of money to go buy engine inventory. So we had to figure out how to be fast without having a lot of buffer. I mean, we certainly still, buffer various long lead time parts, but we're a lot more scientific, a lot more accurate with that now. And our inventory costs are much, much lower for a similar turn time than they were pre-COVID.
Yeah, the one other comment, and this will be the last on this topic, but one of the things I noticed, it was really great to hear, is one of the line techs had gone to one of the training sessions, and they came back and was talking and saying, well, we used to think, because we have 30 people in our shop, that we had 30 different problems, and because everybody's got more than one opinion, we had 60 opinions on what the things to work on were. And his comment was, and I just remember this very specifically, he said, well, we now realize that after the operations science training, that we really only have four main problems, and everybody is working on solving those four main problems. Have you seen that elsewhere?
Yeah, I think people are, variation is one of the things that I've always tried to teach as just an understanding, a conceptual understanding of variation, and it's something that understanding the difference between I always call it common cause and special cause because I'm old school, but really understanding the type of variation that you're experiencing how does that fit within the context of the system? Is it normal? Is it not normal? Are you reacting to something that is just normal, just noise in the process? Or, and so, people, if it's like, you always say, if everything's a problem, nothing's a problem. I mean, you're not going to solve anything if every piece of every time you have some variation, everybody goes chasing it like it's the first time it ever happened. So they get hands-on, that they get some hands-on experience with understanding what that means and how to evaluate it. I mean, that's one of the kind of early stages of the curriculum where, people are getting these basic concepts of flow and demand and utilization and variation. And so, like I said before, it changes the way you think about problem solving. And so if you get, and the first thing that connected with people was, we got to have a somewhat stable system before we can start talking about it in the context of science. Otherwise, it's just chaos, and you can't really do much with chaos. So getting people, this just kind of common understanding of how you think about the operation and variation and stability and control, that's just key, because otherwise it just looks like chaos, and you think that whatever you're doing, whatever firefight you're fighting that day is actually producing some benefit. And then the next day you come in and you look at the gimbal board where, throughput hasn't changed at all. So in other words, we haven't solved a single problem. We're just firefighting every day. So getting people to a place where they can, define, understand, and prioritize problem-solving efforts and continuous improvement, that's a huge piece of the operations science piece.
All right. So let's be remiss if we didn't talk about the hottest topic these days, which is artificial intelligence. Talk a little bit about your experience with that, what y'all are doing with it, and maybe where you see it going.
Well, artificial intelligence is an interesting subject. I personally learned a lot about it over the past few years because of some of the forecasting work that we've done with the engine scrap rates and some of the other tools that have grown out of that. And so, learning how it works and big data and nothing's changed about, the old garbage out, garbage in, garbage out. It's the same as a access database as far as that goes. I mean, artificial intelligence just allows you to make a dumb decision faster, I think, is pretty much what it does. But if you have data structure, and of course there's been a lot of advances in data structure now to even where that's so much, data is so much more accessible now than it was even a few years ago. So the AI part of it, though, for us was just more about, look, let's make sure that we've got all the right parameters in this thing to forecast, scrap rates, for example. And then let AI go in and learn as we iterate, time after time after time. And so, our forecasting models are much more accurate. They scrap rates would be 65 to 70% accurate, before we improve the technologies.
Wow.
But, now we're in the high 80% range most of the time. So, which is pretty accurate. We've been able to reduce inventory levels significantly. Hundreds of millions of dollars, because we're not buying stuff we don't need, and we're much more. It also helps the supply chain in terms of demand, because I can tell some of these suppliers way in advance, this is what I'm going to need. And so their production cycle, because they don't want to build mountains of inventory either. I think there's one thing in common across the industry. Everybody burned off excess inventory during COVID. Like, don't let a good crisis go to waste, right? So now everybody, you need that accuracy, to get the lead times in the range that you need them to be. So we've, definitely got our toes in the water on it, and we're doing some stuff on the reliability side on the airplane side of the airline with operations and predictive maintenance and really understanding failure rates and, being able to proactively change parts before they fail to reduce the amount of downtime of the aircraft and things like that. So it's one of the big advances that I've seen over the last 30 some odd years in the industry for sure.
All right, Mike, we've had some technical difficulties. I appreciate your patience working through all this. That's one of the pleasures of being the pioneer. But let's switch gears a little bit on the conversation. And how did you get to where you are at Delta doing maintenance, repair, and overhaul?
Well, and by the way, don't worry about the rework loop. That's all part of the process, right?
Yeah, that's right. Try and minimize that.
So let's see. I don't know. I started originally at Delta in 1989. I was a machinist and got involved in continuous improvement programs in the mid-90s with some of the lean work they were doing and Six Sigma and other things like that. And, just got interested in, I really was more interested in the science behind all of it than anything else. I think after a while, kind of figured out that consultants have a way of repackaging math in various attractive ways and selling it as different things,
Yeah.
But ultimately, it's the math that works. And so the science behind, variation and understanding capacity and demand and all that kind of stuff was just interesting to me. So I guess I had a knack for problem solving as well. So as I went from one problem to another, working within Delta, mostly on the technical side, some on the cargo side, some on the operations side. I was there until 2004 and went into the consulting business, doing the both continuous improvement type of work. We had some engineering work that we did as well, and did that for about 10 years, mostly airlines, some rapid transit and heavy rail and things like that we did as well. Generally, I would say probably 90% of the work was maintenance, repair, and overhaul. I did some interesting operations stuff at Heathrow and a few other airports, but
when were you at Heathrow? That's interesting. I didn't know that.
I did a project for Virgin Atlantic probably around 2010 or 2009, somewhere.
Oh, okay. We did some work there in 2004 when they were building T5.
Oh, yeah. Okay. Yeah. Yeah, that's a crazy place and interesting problems to overcome there. And that was a fun project. But so then after, I think around 2014, we sold that business, and I had some friends working at Delta, and they wanted me to come back and do some things there. And so I came back to Delta to do originally component maintenance, and then I got engine maintenance added to my list of responsibilities. And then we had a lot of partnership type agreements with other airlines, and wound up, because I had a lot of experience doing the kind of integration stuff with other airlines, I worked with several of our South American partners and Asian partners on projects, and still had my day job. And ultimately they decided I needed to be in corporate strategy. So I was in corporate strategy for about 3 years and working on network kind of problems and integration problems with other airlines. And then I guess after a few years, we started to expand the engine operation with an agreement with Rolls-Royce, and then followed by an agreement with Pratt & Whitney to open a GTF shop, these next generation engine shops. So I came back to the technical side, the maintenance side, and opened the Rolls shop, and then opened the GTF shop. The Rolls shop's about 120,000 square feet, and it does all 5 variants of the Trent engine, which is the large wide body engine that you see on like 787 and A350 and those big airplanes that do international routes. Then the GTF shop's about 150,000 square feet, and both of these are in Atlanta. And then recently we industrialized the LEAP engine, the new GE engine. And so we have all 3 OEM next generation engines and all the next generation problems that come along with that. And so all of that is part of the expansion work that I did on on the Delta Tech Ops side. And so I still have responsibility for all that, as well as the legacy engine fleets. And that kind of thing. But, the operation science has been kind of a part of the process all along, whether it's designing new layouts or
Sure.
looking at, fluctuations in capacity and demand and, overcoming all the supply chain issues with COVID and all that kind of stuff. So it's never a dull moment.
No, I bet not. That's an impressive portfolio, that career path. So, but where did that start? I mean, where'd you grow up? Were you brothers and sisters? How'd you get into machining?
Well, I have a insatiable curiosity, I guess, oddly enough. So I'm a Georgia native, so I'm from here, Atlanta area.
Me too.
And,
Me too.
Oh, all right.
Yeah.
Well, it's not very many Georgia natives in Atlanta these days, but
yeah. Well, I'm in Chicago, so that's how that goes. Yeah.
Well, I got into when I was going to college and working before I landed at Delta, and I was working at a Caterpillar tractor dealership actually. And they had all kind of training courses you could go take, and I'd just sign up for whatever they offered, and everything from I was working in the warehouse actually, but I got to go to all of their maintenance training, and whether it was hydraulics or pneumatics or machining or engines or diesel engines and all that kind of stuff. And I was a kid, so I was whatever I could learn, I would learn, and I was a philosophy major undergraduate, so I figured I probably needed to have a skill.
Wow.
Needed to have a skill and something else, because I don't, generally not a high demand for philosophy majors.
Right.
But I enjoyed. That was it turned out to be a very productive thing to study for me, just in terms of learning how to really think critically, and reading some of the great minds that have tried to tackle some of the larger philosophical challenges of the past and present. So, always been something that I've stuck with. But
it's a great background. It just has to be combined with some hard skills.
Yeah, generally, if you don't want to be hungry. So,
right.
So, I was doing machine work there at the tractor dealership, the Caterpillar dealership here in Atlanta, and had grown up around some Delta people, and Delta was hiring. And so I went to work there. And like I said, after a few years, got involved in some of the continuous improvement stuff, and then went back to school and got an MBA, because I was, I didn't feel quite, I felt like when I would go into a finance meeting, I was bringing a knife to a gunfight. So I needed to go study accounting and finance a little bit to get that side of the resume rounded out a bit, and kind of, too, one of the things you have to do, particularly if you want to get various projects funded, is you got to create value, and you got to be able to measure it, understand how the money flows in a business and that kind of thing. So that was productive. But that's how it unfolded.
Was there any particular person that was an influence on you when you were young? You said you were a teenager when you first started there? Was it Caterpillar?
Yeah. I don't know. Lots of influences over time. A few stand out just for various reasons, not for probably reasons that people think of. I always like to watch leaders and watch people, how they manage other people and how they handle themselves in conflict and things like that. So, probably more of one of the kind of 1,000 influences kind of person than I am a single, North Star type of person. So I've had lots of I've been lucky. I've had a chance to work with lots of really smart people and learn from them. And so it's been fun. I think, kind of that curiosity and desire to learn something new all the time is what kind of gets me up in the morning and keeps me going.
Well, that's awesome. Well, it's morning and you're up, and I'm sure you got to get to work, but it's been an amazing conversation. I really appreciate it. It's been a fascinating experience to listen to your journey, and I appreciate your participating in the first Operation Science podcast.
Yeah, well, I'm excited to see the final product. That'll be great. And the ops science team is off and running. It's really exciting to see it growing at the pace that it is, and the value that's created by this team, and all the really sharp minds that have spent most of their lives developing a lot of this stuff. It's fun to be around. It's great to have the resource for Delta and for me personally. So I appreciate the opportunity to work with you guys.
That sounds great. Thanks, Mike.
Okay, Ed. See you later.
The Operation Science podcast requires more than a conversation. It takes action, research, and collective wisdom. If today's episode resonated with you, we'd love to hear your insights. Join the conversation and help us shape the future together. Join the Operation Science Institute at opscience.org. We'll be back with more stories, strategies, and real-world solutions that are making a difference for everyone. In the meantime, be sure to subscribe, rate, write a review, and share it with someone you think would benefit from it too. Thanks for listening, and see you on the next episode. The views expressed by our guests are their own and do not represent their company's views unless specifically stated as such.